Today we're going to look at a quick review of sinusoidal functions and also application problems involving sinusoidal functions and how we might be utilizing those in calculus. So what I have for you here above is the general formula for a sinusoidal function written in terms of a cosine function. Notice the number in front of the cosine is the amplitude of the function, which is how far it rises above or below the midline. The first number inside brackets is 2 pi over the period. Inside the parentheses, we have our horizontal shift to the right. And then finally, we add the vertical shift to the end. Now, let's look at this in practice. Let's say we have this equation here. Y equals 5 times the cosine of the quantity 2 pi over 3 times the quantity x minus 1, all plus 2. Here are the things that we know. We know that the amplitude is 5. We know that the period of the function is 3, which is how long it will take for a cycle to repeat. We know that the horizontal shift to the right is 1. And the vertical shift of our function is up 2. Now I'm going to sketch the graph using these key pieces of information that I've identified from the function. Now when I sketch a graph, the first thing I always do is determine the midline. The midline is going to be the vertical shift. So notice that since I have a vertical shift of plus 2, I'm going to draw in a dotted line at 2, meaning that that's going to be the middle of the function. We'll go both above and below that line. From there, I'm going to look at the amplitude. Now the amplitude is 5, which means that this function will go 5 above and 5 below the midline at different times. So I'm going to go ahead and create this second and third dotted line, each of those being 5 units from the midline, 1 5 units above, 1 5 units below. So these are kind of the parameters, and I know that my graph is going to cycle between this maximum and the minimum. From here, I want to identify where my first maximum occurs. Because I have a horizontal shift of positive 1, that means that my first maximum will occur at x equals 1. So I'm going to go over 1 and then up to the maximum and draw a point. And the reason I'm starting at a maximum is because this is a cosine function, and positive cosine functions always start at the maximum. Now, the other piece of information that I need to know is the period of the function, which is how long it takes to repeat. And the period of the function is 3 seconds. So if I'm starting at 1, 3 seconds later will get me to 4. So that means it's going to repeat in that distance, meaning that it will be at a maximum again at 4 seconds. Now, if I break this down, because this is cyclical, it follows the same pattern. You know that sinusoidal functions, they go up to a maximum, to the midline, down to a minimum, and then back up. So if it's at a maximum at 1 and 4, it would be a minimum halfway in between these. So that's going to be at 2.5 seconds. Now it's going to cross the midline halfway in between the maximums and minimums. Right, so if I put that in, halfway in between 1 and 2.5 will be 1.75. And then halfway in between 2.5 and 4 will be 3.25. Now what we expect is for you to accurately sketch those 5 points, and then you can just continue the pattern from there, knowing that it should be back at a maximum at 7, and then continue. So that's an example where we are given the function. Let's now look at an example where we are given a word problem and have to pull the information out for ourselves. So here's our problem. A student is studying the swimming patterns of the dolphin named Triggy. The dolphin jumps out of the water and reaches a height of 3 feet. It then dips back under the water and submerged itself 5 feet below the surface of the water. The dolphin first reaches a height of 3 feet at 2 seconds and makes a total of 10 jumps in the span of 1 minute. So we are being asked to both write the equation and sketch a graph. So let's look at the important information that we're given. If you look up here, we know that when he jumps, he reaches a height of 5 feet. So I'm going to make a note to myself that that is the maximum. Other things to pay attention to here, it goes 5 feet below the surface of the water. So that's going to be my minimum. It first reaches a height of 3 feet 2 seconds in. So 2 seconds is going to be my horizontal shift. And it makes a total of 10 jumps per minute. So it's 10 jumps per minute. And that's not going to give me the period of the function explicitly, but it will enable me to find the period of the function. So now let's look at that information to give us a sketch. First of all, I have enough to find my midline right away. So I know that the maximum is at 3 feet. And the minimum is -5 feet. So that's my max and min. To find my midline, I need to find the value that's halfway in between those. So I can do that a variety of ways. I can add them together and divide by 2 to find the average. That will give me -1. So the midline of this function is -1. That is also going to be our vertical shift. So I know the end of my function will have a -1. Now, other things that I know that it reaches its first max 2 seconds in. So I'll do 1, 2, then in a different color here, I'll plot my first point. So it's got its first maximum 2 seconds in. So I also know it's going to be x minus 2. So I'm going to fill in what I know. I don't know the period yet, so I'll leave that part undone. It's a cosine function. And I know the amplitude is 4 because it goes 4 feet above and below the midline. So now let's work on finding the period of the function. Now, if I do 10 jumps in 1 minute, okay, in 1 minute there are 60 seconds. So if I can do 10 jumps in 60 seconds, that means I can do 1 jump in 6 seconds. So the period of the function will be 6 seconds. So I can do 2 pi over 6. Now, you may be noticing that this simplifies. You could very well change that to pi over 3, but again, that's kind of not a big deal right now. So then let's sketch the rest of our function. So again, I know the period is 6 seconds. So if I'm starting my first maximum at 2, then I'm going to get to 8 before I repeat. So I'll do a maximum at 2, and then another maximum at 8. I will have the minimum halfway in between those, so that'll be at 5. And then I'll hit the midline halfway in between those. So halfway in between 2 and 5 would be 3.5. There I'm hitting the midline. And halfway in between 5 and 8 give me 6.5. That's enough for me to get an accurate sketch of my sinusoidal function that I know will continue to repeat in that same fashion. That's all for today. Tomorrow we'll look at how to find the rate of change of these sinusoidal functions.